Okay, we're looking at solving oblique triangles. If you recall from the beginning of the semester, we talked about solving right triangles. The same properties don't hold if it's not a right triangle, so we do have different methods to solving oblique triangles. And depending on the information that we have, well, remember that solving a triangle means that I'm finding all of the missing side lengths and all of the angles. And so depending on the starting information, the way that we actually solve it will change. So the method we're looking at today is called the law of sines. And the law of sines works if we have ASA, AAS, or SSA. And we'll look in just a second what the heck these things mean. But side, so this is side angle. This is the ambiguous case. This is a special case, and we'll look at it more in depth in just a second. But what do these things mean? So we have angles and we have side lengths. So A stands for an angle and S stands for a side. So once we're given our information, first thing you're going to want to do is draw a triangle and look at what order the information they give you is. Remember that each angle has a corresponding side. So let's say this is angle B, then side B will go across from it, like that. So let's say that I am given angle B, side B, and angle A up here. Right? So this is, I have a side and then an angle and an angle. So this would be side, angle, angle. So this is angle, angle, side. If it were angle, side, angle, then the side would be in between my two angles. So that would be something like, here's angle A, this would be side C, and angle B. So notice I have angle, side, angle. Right? So the placement is sometimes going to make a difference. In this case, if I have either one of these situations, then I'm using the law of sines, and it's very straightforward. Side angle, let me do an example of that, but that would be, say I have side C, side A, and then angle C. So I have two sides, and then the angle, not the included angle, and angle off to the side. So this would be side angle. And we call this the ambiguous case, and it gets special treatment. So let's jump in and actually look at what is the law of sines and how do I use it. So the law of sines is a ratio between corresponding side lengths and angles. What the law of sines actually says, law of sines, actually says is that sine of angle A divided by side A is equal to sine of angle B divided by side B, and that's equal to sine of angle C divided by side C. And depending on the information that we have, we'll use pieces of this ratio. So let's jump in and actually do an example using this information. All right, so let's say I'm given that angle B is 38 degrees, angle C is 21 degrees, and side B is 24. Now today we're just using law of sines, but next class when we look at law of cosines, it's going to be especially important that we draw a triangle and figure out exactly what method I'll be using. So I have angle B, angle C, and side B. So I have angle, angle, side, angle, angle, side. And if you look at, on the back of your homework, there's a nice little printout that tells you exactly what to do depending on the information you're given. So here, procedure for angle, angle, side. We're going to find the other angle just by subtracting the two given angles from 180, and then we'll use the law of sines to find our other side. So nothing fancy or special, just using the law of sines. So I have these two angles. Remember that the total angles in any triangle will be 180. So we can go ahead and find angle A. by doing 180 minus 38 minus 21. And that is going to give us 180 minus 59. So we get 121. So angle A is 121 degrees. And so now I need to find side A and I need to find side C. It doesn't matter which one we start with in this case, so I'm going to go ahead and I'm going to start with side A. I want to find side A, so I know that I need to use the part of the ratio that deals with A. And looking at the information I have both angle B and side B, so I want to use that part of the ratio as well. So I'm going to be, this is side A, I'll be using sine of A divided by A equals sine of B divided by B. And we'll use this to solve for A. So we know we found angle A is 121, so I have sine of 121 degrees divided by A is what we're looking for, equals sine of B, which is 38 degrees, so sine of 38 degrees, divided by, I know that side B is 24. So I can figure out what all these values are first, or solve my equation first. Grab a calculator real quick. Alright, so we can solve this just as a proportion, which is what it is, by cross multiplying and then dividing by the other value. So cross multiplying, I get A times sine of 38 degrees equals 24 times sine of 121 degrees. And my goal is to get A by itself, so I'll divide both sides by sine of 38. So I get A is equal to 24 sine of 121 degrees divided by sine of 38 degrees. And making sure that my calculator is in degrees. So I'll go to mode, go to degrees. You can't see that. I'm using a TI-84, but your calculator should have a similar setting. I'm in degrees. So 24 times sine of 121 divided by sine of 38 gives me 33.4 approximately. So side A is approximately 33.4 feet or degrees or whatever. And now we're trying to find side C. So we'll do something essentially the same exact thing. But instead of using the ratio part for A, we'll use the ratio part for C. And we can keep all the same information for B. So now to find side C. I'll have sine of C over C equals sine of B divided by B. And again, filling in all of my information, we're given that angle C is 21. So I have sine 21 degrees over C, which is what we're trying to find, is equal to sine of 38 degrees, which is what we're given, divided by 24, which again is what we're given. And now we'll solve this in the same exact manner that we solved the last one, as a proportion, cross multiply, divide by the value in front. So I end up that C is equal to 24 sine of 21 degrees divided by sine of 38 degrees, which again we're working in degrees, so make sure your calculator is in degrees. And I have 24 sine of 21 divided by sine of 38. It's going to give me approximately 13.97. And so there we go. We found all of the missing pieces. So we were given, scooch up here, we were given that angle B was equal to 38 degrees and angle C was equal to 21 degrees. And we found that angle A was equal to 121 degrees. Yes. Alright, and we were also given that side B was 24. We found side C to be 13.97, approximately, and that side A was approximately 33.4. And if you recall, a good way to kind of check if our answer even makes sense, the smallest angle should be associated with the smallest side, and the largest angle should be associated with the largest side. And that does add up, so I'm pretty certain that we did this correctly. Okay, all right. That is solving a triangle given angle, angle, side. It works essentially the same for angle, side, angle. So check out the next video and we'll look at the ambiguous case.